All right, so we're going to just discuss the Pythagorean theorem. It's something that you've done earlier in 7th, 8th grade, but we'll just touch on it now because we're going to use it so often. And the Pythagorean theorem just says that for any right triangle, that the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So if you just add up the area of these two squares, you get the area of that square, right? And so the idea is, regardless of how long this is, it's a length of A, this is the length of B, this is the length of C. So we say A squared plus B squared equals C squared. In this case, you can see this length is 3. The length along the bottom is 4. The area of 3 squared is 9. Area of the 4 by 4, right, that's 16. And we can say A squared plus B squared equals C squared. The area of 9 plus 16 equals C squared. 9 plus 16 is 25. And we know that we need to square root both sides to solve for C. And we're just taking the positive area, or the positive length of 5. So this is a length of 5. Okay, so that's the Pythagorean theorem. I know you've seen it before, but we'll just take some quick notes on it. All right, so we're going to say that in a right triangle, this is true for all right triangles only, that the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Okay, and the hypotenuse is always the side that's opposite the right angle. And we usually label that side as C. Okay, so the Pythagorean theorem says A squared plus B squared is equal to C squared. A Pythagorean triple is just any set of 3 numbers that makes that equation true. Okay, so any set of 3 positive integers that make this true. Okay, and we'll write a few of those on the next page. All right, so this one just says A is 12, B is 5, find your C. So A squared plus B squared is equal to C squared. Substitute in the values for A and B. So we have 144 plus 25 is equal to C squared. 169 equals C squared. We square root both sides to cancel out the square to get the C by itself. And again, we're taking the positive answer here of 13. So that makes the triple 5, 12, 13. That group of numbers is a Pythagorean triple because they make that equation true. All right, so in this case, you're finding A, meaning we know our C, but we need to work backwards and find our A. It doesn't matter. We still set up the equation the same way. A squared plus B squared equals C squared. We don't know A. B is 2. C is 4. Okay, so A squared plus 4 is equal to 16. Take away the 4. A squared is equal to 12. We square root both sides. Now, we've been doing this already, that we have to simplify our radicals. And so, in class, I had mentioned that we can factor 12 into its prime factorization of 2 times 2 times 3, and we take out any group of 2, or any pair. All right, so our final answer for A is 2 root 3. All right, so here's 2 for you to do, one where you find C, one where you find A. All right, a lot of these Pythagorean triples are really common, and I've shown you on my wall that I have a poster ball, a lot of the common triples. And the most common Pythagorean triple is the 3, 4, 5. 3 squared plus 4 squared equals 5 squared. 5, 12, 13 is another one. 7, 24, 25 is another one. Right? There's a lot of these. But it's good to know a few of them just and to memorize a few. But Pythagorean triples that are multiples of other Pythagorean triples are said to be in the same family. Okay, so here's the kind of like the parent, the 3, 4, 5. But any multiple of that is also a Pythagorean triple. So if you double all these and get 6, 8, 10, that's also a Pythagorean triple. If you triple all these, right, and you get 9, 12, 15, that also is a Pythagorean triple. If you half all these, right, so then you'd have 3 halves, 2, 5 halves. That's also a Pythagorean triple. So those are all in the same family as the 3, 4, 5. All right, so just write any other 3 that are in the same family as 5, 12, 13. Okay, and this kind of last big idea is the Pythagorean theorem is true for right triangles. A squared plus b squared equals c squared. So if that's true, we know the triangle is a right triangle. But what happens if a squared plus b squared is bigger than c squared? Meaning, the area of these two is larger than the area of that one. Well, what kind of triangle must this be if the area of those is greater than the area of this one? So imagine this is getting smaller, these are getting bigger. How would this triangle change shape? Well, either it's going to be acute or obtuse. And if the area of the legs is greater than the area of the hypotenuse, well, if a squared plus b squared is greater than c squared, then we're dealing with an acute triangle. And if the a squared plus b squared is less than the c squared, that third side is a lot bigger than the other two, then we're dealing with an obtuse. Right, so if I give you 3 lengths, maybe they're in a family, maybe they're a Pythagorean triple, or maybe this represents a different kind of triangle. The largest always is your c. So it doesn't matter which one's a and b, but the largest is c. So we say, does 5 squared plus 9 squared equal 13 squared? Okay, so 25 plus 81 equals 169. Remember, this is kind of like we're questioning, are they equal, or are they less than, or is it greater than? Well, here we get 106, and that is not equal to 169. That is actually less than. So if the sides are less than the third, we're dealing with an obtuse triangle. So determine the type of triangle. This one is obtuse. All right, so you're going to do that one. And lastly, you need to be able to just use the Pythagorean theorem in a variety of scenarios. You know, not every time you're just given a single triangle. In this case, you're given a rhombus. All the side lengths are 10, so it's a good idea to label everything. Sometimes things don't pop out until you label them. And one of the properties here is that the diagonals of a rhombus intersect at 90 degrees. So we're dealing with the right triangle there. And now we can see that we have an a squared, b squared, c squared relationship, so we can write x squared plus 6 squared is equal to 10 squared. Just do our algebra, isolate the x. So x squared is equal to 64. Square root both sides, and again, there are 2 answers, plus or minus 8. We're only taking the positive answer because we're dealing with length. All right, so that's it. Solve for x on this one. I'll check this when you come back to class. If you have any questions, let me know. I can post up a video, some other Pythagorean theorem videos too if you need to see it. All right, thanks.